Okay, this week we're going to be looking at confidence intervals in part. So, a confidence interval is an estimation, and it could be about a mean or a proportion. And it's an interval that estimates a range of values that contains or captures the true population value for the variable of interest. Again, a mean or a proportion. Implicit in this concept is a level of confidence that is the actual / true population value, that this actual true population value is contained within the estimated range of values. So if you go to buy a new car, if you're lucky enough to buy a new car, and you go and you look at the sticker and it tells you how many miles per gallon that vehicle gets, that's actually from a confidence interval. If you was to go look, you'll see, let's say it gets, 20 miles per gallon. If you look below that, you're going to see an interval below that may be between 15 and 25. And they just chose the one in the center. So that is basically what a confidence interval is. It estimates a range that tries to capture the true population value that you're looking for. Because it's not feasible to obviously do a census of every vehicle that rolls off the lot that's a certain model. You would just take a sample of that, record their miles per gallon, and construct a confidence interval. So I do have the most commonly used confidence interval levels, the critical values. So you're going to be using a z sub alpha over 2 in your formulas. But I'm going to show you that, but we're going to be using technology to calculate these. So most of your vehicles, by the way, I think use on the miles per gallon new vehicles, they use a 90% confidence interval because your alpha level is 0.1. That means you're 90% confident that the true value for, let's say, the mean miles per gallon for the vehicle is between, that certain value, the range. It's going to be an open interval. So the critical value that's associated with 90% is alpha 0.10. You have to look at z sub alpha over 2. And when you calculate that, you get 1.645. Another commonly used confidence interval or level is 95%. So alpha equals here 0.05. So you see how we're getting alpha? We're subtracting, if you're making this 0.90, subtract that from 1, you get 0.10, so on and so forth. And 99%, again, most commonly used value. So I'm going to show you how to calculate one of them. So you don't have to calculate these. These are given to you. If you were given like a 98% one, you might have to calculate that, but I don't think I'll have any in there for you like that because these are the most commonly used ones. So if you draw your standard normal curve, and this is for the 95% confidence interval. So since it uses z sub alpha over 2, I have to take the 0.05, or excuse me, the 95, and I have to divide that by 2, which means the area here and the area here and the tails all the way out to the end. By the way, it should go all the way to the end. We know that it never really reaches the end, but we know that those values are going to be, okay, half of 0.05 is going to be 0.025, and here's 0.025. Okay, since this is symmetric, and I know this is going to be negative, I can simply put this in my calculator, inverse norm. If I do the 0.025, you know that the inverse norm gives the value to the left. It's going to be a negative. So we know that this one here is negative 1.96, and they do round this one to 2 places, but notice that these other two, they require you to go 3 places with it. So I know that this one is positive 1.96. So notice that in the confidence interval, we always use the positive value when we're calculating it, okay? Because you're going to have the z sub alpha over 2, and then you're going to have some other the rest of the formula in there, depending on whether you're using the mean or a proportion. So you don't have to, you can just simply use those, but that's how it's calculated. We always use a positive. So let's look here in a reading for week 5. So notice that they start out here with some information about the confidence intervals. Okay, looks like they're going to be doing the mean first. Okay, so you can read through all of that. Now, this is one place where it says calculate the confidence interval. Again, we're going to use technology, but sometimes you're going to be asked to find the margin of error. Now, most books call this x minus the margin of error, x bar, comma, x bar plus the margin of error. It's usually abbreviated ME. This is the only book that I've ever seen that calls this the error bound for a population mean. It's called margin of error, whether it is for a proportion or for a mean margin of error. But this book uses EBM. Okay, so just let you know that, point that out. Okay, so go ahead and read. That talks about the central limit theorem. Gives you some information on the TI. We'll be probably more than likely using StatDisk. Let's see. Yeah, here we go. The point estimate for the population mean mu is going to be x bar. Okay, and then when we also for the population proportion, we'll be using something called p hat, and that may be in this one right here. Well, p prime will mostly be using p hat, and that's a p with a little part of a triangle over top of it, red p hat. So make sure that you have read through. We're only going from 8.1, 8.2, and 8.3 is all you have to read for this section. Okay, one thing that I forgot to add here is that these critical values are for population proportions. And also for population means. And here's a big if, when your sigma, which is your population standard deviation, is known. I'll add that in there. Because if your population standard deviation is not known, then instead of using a z sub alpha over 2, we're going to be using a t sub alpha over 2, and I will have some common values for there. So just wanted to point that part out to you. Let me know if you have any questions. Thanks.